In this video, I'll discuss how to find binomial coefficient using dynamic programming. The recurrence relation to find the binomial coefficient is Cnk equal to Cn minus 1k plus Cn minus 1k minus 1 for n greater than k greater than 0, Cn0 equal to 1, Cnn equal to 1 for n greater than or equal to 0. So whenever you apply this recurrence relation for some instance of the problem, then this results in overlapping subproblems. So dynamic programming is most suitable for the recurrence related overlapping subproblem. So this binomial coefficient can be solved by using dynamic programming approach. Now in order to find out Cnk, you are required to know what is Cn minus 1k and Cn minus 1 k minus 1. Look at the table here. In order to find out this, you need to know in the previous row and in the same column what is the value recorded. Also, previous row, previous column value recorded. If you know these two values, then adding these two values will give you Cnk. Initial conditions for filling this table is Cn0 equal to 1, Cnn equal to 1. Look at here. Diagonal elements will be equal to 1 and the first column, that is 0th column, all equal to 1 irrespective of the I value. So I am taking I here in order to vary from 0 to n. So I is taking the value from 0 to n and j is taking the value from 0 to k. Since it's a combination here, if you have 0 item, you cannot choose more than 0 item, right? So if you have 1 item, maximum you can choose 0 item or 1 item. You cannot choose 2 item. Obviously, k will take the value less than or equal to n. So always k will be less than or equal to n. So it cannot go beyond that. So whenever you are giving the input for k, you have to take care that k must be less than or equal to n. I'll just take one instance here to find Cnk, that is C64. For this, we'll see how to apply this recurrence relation and how to fill the table. We'll see with the example. Since it is 64, n is 6 and k is 4, 7 rows, because starting from 0, 7 rows and 5 columns. The table should be containing 7 rows and 5 columns. Now here C00 is 1, C10 initial condition 1, C11 is 1, C20 is 1, C21 is nothing but go to the previous row, in the same column value recorded is 1 and previous row, previous column value recorded is 1. So summation of these two will give you 2 and here 1. So similarly 30 is 1, 31. How do you find this? Previous row 2, previous row, previous column is 1, 1 plus 2 is 3 and similarly in order to find this, here these two values is being considered. So 3. Now 3 is 1, 40 is 1, 41. How do you find 41? Previous row in the same column 3 is there and here 1, 1 plus 3, 3 plus 3, 3 plus 1. Okay. Then 5. In the 5th row it is 1, then 5, 10, 10, 5 and 6, 1 is 6, 6, 2. How do you find 6, 2 here? previous row in the same column 10, previous row, previous column is 5. So 5 plus 10, 15, then 10 plus 10, 20, and previous row, previous column is 5, previous row, previous column is 10. So previous row in the same column value recorded is 5 plus previous row and previous column value recorded is 10. 10 plus 5 is 15. So this is what we are required to find out. In order to find out this value, you are required to fill the intermediate values also. Then only you can find C and K. Okay. Now we'll see the algorithm for this. In order to find this, you need to vary loop from 0 to 6, that is 0 to n. I is varied from 0 to n and j must be varied from 0 to minimum of I comma k. In this case, k value is 4. In the 0th row, we are considering 0, 0. 0, 1, you are not supposed to find, right? You cannot choose one item when there is 0 items, right? So, minimum of I comma k you are required to find out. So, j should be varied from 0 to minimum of I comma k. Then, when I equal to j, then C ij will be equal to 1, and if j equal to 0, then Cij will be equal to 1. Otherwise, what you are required to do is Cij will be equal to, in the previous row, the value recorded you have to find out, and previous row, previous column. Then previous row, same column is Ci minus 1 j plus Ci minus 1 j minus 1. This is what the algorithm is. I will just explain here. So binomial n comma k, n and k, you have to take the value greater than or equal to 0, and obviously n should be greater than or equal to k. So vary I from 0 to n, vary I from 0 to n, and j from 0 to minimum of I comma k. Then if j equal to 0 or j equal to I, then Cij must be set to the value 1. Otherwise, Cij will be equal to Ci minus 1 j plus Ci minus 1 j minus 1. So, after completing all the iterations, you will be getting C and K that you are required to return to the main. This is the pseudocode to find binomial coefficient. The time and space complexity of this binomial coefficient, obviously it's equal to theta of n into k. Right? We'll see how to analyze this algorithm. Basic operation, what you are performing here is addition. In order to find out this, you are required to add these two. In order to find out these values, you are required to add these 2 and 1. That means in general, if you want to find out C and K, you are required to add Cn minus 1k plus Cn minus 1 k minus 1. So the basic operation performed in this algorithm is addition. You are required to count how many additions is required to carry out in order to find out C, N, K. So number of additions performed in the algorithm, it is dependent on both N and K. So obviously, in order to count number of additions, so addition is expressed as function of N and K. So A, N, K will be equal to number of additions in the triangle plus number of additions in the rectangle. Here n value is 6 and k value is 4. So A64 is equal to number of additions in the triangle is 1, 2, 3, 4, 5, 6. 6 additions in triangle and 1, 2, 3, 4. 4 plus 4. 8 additions in the rectangle. Right. So totally 14 additions is being carried out in order to find C6, 4. We'll see in general how many additions you are required to carry out in triangle separately and rectangle separately. Addition of these two will give you total number of additions carried out in order to find C, N, K. Okay. So in this example, first 5 rows is forming the triangle. First 5 rows including 0. That means here K value is 4. That is K plus 1 rows is forming triangle. Remaining 2 rows. Remaining 2 here is nothing but N minus K rows are forming rectangle. So first K plus 1 rows forming the triangle. Remaining N minus K rows forming the rectangle. You are required to count how many additions is being done in triangle plus how many additions is being done in the rectangle. Together will give you total number of additions to find C, N, K. So this is the equation. Total number of additions is equal to number of additions in triangle plus number of additions in rectangle. We require to find out total number of additions in triangle. Let me explain with the example. Here I is varied from, this is the base condition anyway, 0, 0, no need to count that. I is varied from 1 to, this is the K value, right? So 1 to K. I is varied from 1 to K and J is varied from 1 to I minus 1. So 1 to I minus 1. Look at here, 2, 2 is base condition. Diagonal value always equal to 1. So you are not supposed to find out CII. How long you are required to find out the values? Till CI minus 1. So obviously you have to vary the loop from 1 to I minus 1. J should be varied from 1 to I minus 1. I'll be repeating again here. Vary the row, that is I, from 1 to K and J from 1 to I minus 1, because I comma I will be equal to 1. No need to find out I comma I. You are required to find out till I minus 1. So J should be varied from 1 to I minus 1. So that is what is being written here. I is varied from 1 to K and J from 1 to I minus 1, and in each iteration we will be carrying out one addition. We'll see in the rectangle how many additions you are carrying out. So here I is varied from K plus 1 to N and J is varied from 1 to K. Look at here, I is varied from K plus 1 to N, J from 1 to K, and in each iteration we are carrying out one addition. So simplify this summation. When you simplify in a summation, the summation result here is upper limit minus lower limit plus 1. So this 1 get cancelled. With that, what results here is I minus 1. And in this case, K minus 1 plus 1. So result is K here. Now I is taking the value from 1 to K. Substitute that values in this I minus 1. When you substitute, the end result is 0 plus 1 plus 2 plus 3 so on up to K minus 1. So sum of natural number up to K minus 1 terms, it's equal to K into K minus 1 by 2, and here k is constant. So take out from the summation k into summation of this upper limit is n and lower limit is k plus 1 and 1. So when you when you apply the summation to that, upper limit minus lower limit plus 1 into k, the result is k into n minus k. So look at here, this is the total number of additions being performed in order to find out C and K. So we will see in the previous example, are we getting the same thing or not. So here number of additions in triangle is 6 and number of additions in rectangle is 8. And what is the n value here? N value is 6 and k value is 4. So k value, apply k value here, 4. 4 into 4 minus 1, 3. That is 6. And here 4 into 6 minus 4, that is 2. So total 8. The same thing we are getting here. This is how you can calculate or find out the time complexity of this binomial coefficient. And the complexity of this algorithm belongs to theta of n into